So we're working with the same headphones company. We just found their revenue function, we took the derivative of it, and we used that derivative to maximize the revenue and figure out what the maximum revenue was. And now this same wireless headphone company is giving us a little more information. So the wireless headphone company estimates the total cost in dollars incurred in manufacturing X headphones in their first year of production will be given by this total cost function here. C of X, which is 209X plus 170,000. And we want to use this cost function to find profit. Well, profit in general is called P of X, and it's always a capital P. And we're going to take the revenue minus the cost. So it's always revenue minus the cost. And the most important thing here is that you remember to distribute this negative. We're subtracting the entire cost function. So I'm just going to put that little symbol there. So we want to find the profit for this specific company. So I'm going to need their revenue function, which we actually found on the page before. So I'm going to flip back. Our revenue function was negative 0.085x squared plus 900x. I'm going to use that here for their revenue, negative 0.085x squared plus 900x. There's my revenue. And I need to subtract the entire cost function, not just the first term. So I'm going to subtract the whole cost function. I'm going to put parentheses in. It's 209x plus 170,000. And that was just given to me in the problem. I didn't have to find it like I did the revenue on the page before. So I'm using this cost function that was given to me above there. So I'm going to find the profit function by just distributing now. So I'm going to take this negative and subtract not just 209x, but I'm going to also subtract this 170,000. So the profit is going to be negative 0.085x squared. No like terms to combine there. But then my 900x is going to have 209x subtracted from it, which is going to leave me with 691x. And then I have minus 170,000 at the end. And that makes sense that I have a negative number at the end because my profit, if I sell nothing, and I paid a whole bunch of money to make all of these wireless headphones, and then I end up selling none of them, I should have a negative profit. So it makes complete sense to always have a negative number there at the end. So we have minus 170,000. We're going to be out a lot of money if we sell none of these wireless headphones. So if we had plus at the end, if we forgot to distribute, it would really make no sense to have a huge profit if you've sold nothing. The next part says find the marginal profit. So no formula for marginal. Marginal means take the derivative of profit. So I'm going to call it P prime of X. And I'm going to bring down my power, negative 0.085. Bring down the 2 is going to be negative 0.17. X to the first. The derivative of 691x is 691. And the derivative of negative 170,000, that's a constant. So the derivative is 0. The last part says what value of X would maximize your profit and what is the maximum profit. So first we're going to figure out what value of X would maximize your profit. If you're asked to find the max or min of anything, you always take the derivative for your first step and set it equal to 0 and then make a sign chart. So I'm going to take the derivative, which I already did above. So that's done. It was negative 0.17x plus 691. And we're going to set that equal to 0. Because if we want to maximize profit, we're going to take the derivative of profit and set it equal to 0. So to solve for this, I need to move the 691. So I'm going to subtract it over to the other side. We're going to have negative 0.17x equals negative 691. And then to get x by itself now, I'm going to have to divide. So I'm going to divide both sides by negative 0.17. And I might need my calculator for this. We're talking about headphones, so we're going to have to take the nearest whole number. And our x value that we get is about 4,065. And this is a real life problem, so we want to figure out what x means. Well, x is headphones. So to maximize their profit, we're saying you should make 4,065 headphones. But we don't want to tell them to just make that amount without double checking that it really is a maximum, because it would be terrible to advise this company and have us minimize their profit. That would definitely lose our jobs. So let's double check this is a maximum by making a sign chart. I'm going to label 4065 because this is important. This is our critical number. Makes the first derivative 0. So I'm going to say, nice label on this, p prime of x is 0 here. And if we look to each side, we can plug in any number we want. Maybe I'll just plug in 1 here and see what happens to the derivative. Well, negative 0.17 times 1 plus 691 is still going to be positive. So we're going to be positive before our critical number. Good sign so far that it could be a max. But I have to check something after. So maybe I'll plug in 5,000, and I might need to grab my calculator for this. Negative 0.17 times 5,000 would be negative 850 plus 691. And again, of course, I'm always plugging into the derivative on a sign chart, and I get a negative derivative here. So I went from a positive derivative to a negative derivative. So we really do have a max. And we really are going to tell them to make 4,065 headphones. And then the next part says, what is the maximum profit? Because of course they're going to want to know, well, how much money are we going to make off of this? So for their maximum profit, we're going to plug into the profit function and see what the y value is here. So we would plug it on our calculator, 4065 in for both of these x's. So I would do negative 0.085 times 4065 squared. And you need to put that 4065 in parentheses because you have to do PEMDAS exponents first. Plus 691 times 4065 minus 170,000. And I am getting a pretty big number here. $1,234,355. And it's money, so we can round to the nearest cent. And it's about 88 cents for the max profit. So you just plug in and find the y value into the original. If I accidentally plugged into the derivative, I would know because I would get 0 out if I plugged this value into the derivative, since that's what made the derivative 0. But here's my actual profit. Something to think about. We just talked about the same company. Their maximum profit is about 1.2 million. And we're telling them to make 4,065 headphones. Whereas for the same company, we just told them, hey, you should make about 5,300 headphones for a max revenue of $2.4-ish million. So what should they do? There's a couple different ways to interpret this. I would probably not ask you this on a test, but just something to think about. At the end of the day, what matters more, having this 2.4 in revenue versus this 1.2 in profit? Even though it's less money, you'd probably want to go with what's more profit, because at some point your cost is going to outweigh the benefits, and the revenue is just the amount of money you take in, whereas, hey, this profit is really what you're able to take home because it takes into consideration, it subtracts out the cost. So I would go with what maximizes the profit, but we'll notice that they don't always agree. What maximizes the revenue does not necessarily maximize your profit. So the company will have to decide what's more important to them.